Hello, beautifuls. This is Atleen, and I'm coming to you with another video. So today we will be reading out of the CCNA 200-301, Volume 1, CERT Guide by Wendell Odom. Chapter 11, Perspectives on IPv4 Subnetting, Network Fundamentals. The key facts about subnets is what we'll be discussing, as well as rules about places in a network topology that need a subnet. And after our reading, we will go over, do I know this already? And there are 1 through 7. And we will start reading with Introduction to Subnetting. So you just happened to be at the sandwich shop when it was selling the variety of the world's longest sandwich. You're pretty much hungry, so you go for it, and now you have one sandwich. But because it's over 2 kilometers long, which is really long, you realize it's a bit more than you need for lunch all by yourself. To make the sandwich more useful and more portable, you chop the sandwich into meal-sized pieces and give the pieces to other folks around you who you are already having lunch with. Well, subnetting, at least the main concept, is similar to this sandwich story. You start with one network, but it is just one large network. As a single large entity, it might not be useful, and it probably is far too large. So to make it useful, you chop it into smaller pieces called subnets and assign those subnets to be used in different parts of the enterprise internetwork. And with internetwork, we do use those words interchangeably with subdivided network, subset, subnet. Those words are really all the same. Okay, so this short first section of this chapter introduces IP subnetting. First, it shows the general ideas behind a completed subnet design that indeed chops or subnets one network into subnets. The rest of this section describes the many design steps that you will take to create just such a subnet design. By the end of this section, you should have the right context to then read through the subnetting design steps introduced throughout the rest of this chapter. Subnetting defined through a simple example. An IP network, in other words, a class A, a class B, or C network, is simply a set of consecutively numbered IP addresses that follows some preset rules. These class A, B, and C rules define that for a given network, all the addresses in the network have the same value in some of the octets of their addresses. For example, a Class B network, as shown in this diagram, network is 172.16.0.0, which you can see that's a private address, consists of all IP addresses that begin with 172.16. So that's what they have in common, 172.16. And as you can see, as you go around, that the first three octets are equal. Consist of all IP addresses that begin with 172.116. So it's 172.16.0.0, 172.16.0.1, 172.16.02, 172.16.0.2, and so on through 172.16.255. Another example, Class A network 10.0.0.0 includes all addresses that begin with 10, and that's another private address. Okay, so an IP subnet is simply a subset of a Class A, B, or C network. In fact, the word subnet is a shortened version of the phrase subdivided network. For example, one subnet of Class B network 172.16.0.0 could be the set of all IP addresses that begin with 172.16.1 and would include 172.16.1.0, 172.16.1.1, 172.16.1.2, and so on, up through 172.16.1.255. Another subnet of that same class network can be all addresses that begin with 172.16.2. To give you a general idea, Figure 11-1 shows some basic documentation from a completed subnet design that can be used when an engineer subnets Class B network 172.16.0.0, as you can see here in the diagram. So the design shows 5 subnets, one for each of the 3 LANs and one for the 2 WAN links. The small text note shows the rationale used by the engineer for the subnets. Each subnet includes addresses that have the same value in the first 3 octets. For example, the LAN on the left, the number shows 172.16.1, as you can see, 172.6.1. Also note that the design as shown does not use all the addresses in Class B network 172.16.0.0, so the engineer has plenty left of room for growth. Operational operational view versus design view of subnetting. Most IT jobs require you to work with subnetting from an operational view. That is, someone else before you got the job designed how IP addressing and subnetting would work for that particular enterprise network. You need to interpret what someone else has already chosen. To fully understand IP addressing and subnetting, you need to think about subnetting from both a design and operational perspective. For example, Figure 11-1 simply states that in all these subnets, the first three octets must be equal. Why was that convention chosen? What alternatives exist? Would those alternatives be better for your internet for today? All these questions relate more to subnetting design rather to operation. To help you see both perspectives, this chapter focuses more on design issues by moving through the entire design process for the purpose of introducing the bigger picture of IP subnetting. The next three chapters each take one topic from this chapter and examine it more closely, but more from an operational perspective, how to use those ideas in real networks. The remaining three main sections of this chapter examine each of the steps listed in Figure 11-2 in sequence, and we will be discussing each one each day. So today we are discussing subnet planning, analyze the needs, subnets, host, subnet, one size subnet. The second is design subnets. The third is plan implementation. We will go over each one each day. We will now read about rules about which hosts are in which subnet. Every device that connects to an IP internetwork needs to have an IP address. These devices include computers used by end users, servers, mobile phones, laptops, IP phones, tablets, and networking devices like routers, switches, and firewalls. In short, any device that uses IP to send and receive packets needs an IP address. And note, in a discussion of IP addressing, the term network has specific meaning. A class A, B, or C IP network. The IP addresses must be assigned according to some basic rules and for good reasons. To make routing work efficiently, IP addressing rules group addresses into groups called subnets. The rules are as follows. 1. Addresses in the same subnet are not separated by a router. 2. Addresses in different subnets are separated by at least one router. Figure 11-3 shows the general concept with host A and B in one subnet and host C in another. In particular, note that hosts A and B are not separated from each other by any routers. However, host C separated from A and B by at least one router must be in a different subnet. Okay, so I will now go over, do I know this already? And question 6 states, before class B network 172.16.0.0 is subnetted by a network engineer, what parts of the structure of the IP address in this network already exists with a specific size, and it says choose two answers. Now this is before we decide to chop it up to break it down, before we get it subnetted by a network engineer. So the two parts that exist is A, the network, and C, the host. Okay, well, I'll see you tomorrow. Keep studying, and I wish you well.